Hello everyone, welcome to the new video tutorial of Bioenzyme. In the last session we have dealt about the first part of tissue system, that is the medicinal tissues. In this session we will be dealing with the second part, that is permanent tissue system. If you haven't subscribed to our channel, subscribe to it and enable the bell icon to get daily notification. So without wasting time, let's get on with the video. Basically, permanent tissues are tissues derived from mesenchymal tissues. That is, the mesenchymal tissues lose the ability to grow or multiply, and it undergoes differentiation and takes up a particular function which helps in sustenance of plant. So, such type of tissues is known as permanent tissues. Now, basically, at the basic level, we can classify permanent tissues into two. That is, primary permanent, and the second one is secondary permanent. Primary permanent tissues are the tissues which are developed without the secondary growth. That is the tissue which we normally see in the plant, that is the cortex, the primary xylem, primary phloem are all primary permanent tissues. So that primary permanent tissues is derived from the apical meristem. Now second one is secondary permanent tissues. These tissues are developed after secondary growth. For example, secondary xylem, secondary phloem, etc. are developed after the secondary growth, and these tissues are termed as secondary permanent tissues. Now these secondary permanent tissues are derived from the lateral meristem. Now actually the second most known classification of permanent tissues which we all have studied in our high school is that the classification is, first one is simple permanent tissue and second one is complex permanent tissue. Simple permanent tissues are a group of same cells functioning to do a same function. Now second one is complex permanent tissue, is a group of different cells but performing the same function. That is the main difference. So first let's focus on simple permanent tissues. The first simple permanent tissue is parenchyma. Parenchyma is the normal tissues which is very common in the plant tissue system, that is which is occur more frequently. If you take a section of the plant, the most common type of permanent tissue is parenchyma. It may be of different shapes varying from irregular, isodiametric, etc. The main point related to the parenchyma is that it is primordial. The first formed simple permanent tissue is said to be parenchyma. The other all simple permanent tissues are derived from the parenchyma. It is a living tissue, and the two modifications of parenchyma is erenchyma and chlorenchyma. Erenchyma is a parenchyma tissue modification in which it helps hydrophytic plants to float in the water. So it stores air and helps in the buoyancy. Now second one is chlorenchyma, that is it has chlorophyll and helps in photosynthesis. This chlorenchyma is mainly seen in the leaves. That is it may be palisade or sponge, you have heard about it in the leaf sections. So that is what we have to mainly focus on parenchyma. Now the second simple permanent tissue is chlorenchyma. It is a living tissue, and the main function is that it is the only living mechanical tissue which supports the plant. So it is living, and it is a mechanical tissue and helps in supporting the plant. So it is the only living mechanical tissue seen in the plants. The second point is that the intercellular spaces is normally absent, whereas in the case of parenchyma there is a lot of intercellular spaces, but in the case of chlorenchyma normally intercellular spaces are absent, except in the case of lacunar chlorenchyma of lettuce cell. So lacunar chlorenchyma is a type of chlorenchyma which we have to discuss. Now let's see the different types of chlorenchyma in detail. Now we have to discuss the three types of chlorenchyma tissues. The first one is angular, the second one is lamellar, the third one is tubular. Now what is the difference? The difference is mainly in the arrangement of cells and also thickening of the cell wall. Now the first one is angular type, in which the cells are irregularly arranged. There is no intercellular spaces, but the cells are arranged irregularly. The second one is lamellar type, in which the cells are arranged tangentially or radial arrangement. The third one is tubular, in which the cells are arranged in tubular arrangement, and the main feature is that there is intercellular spaces in some plants. So in first two, that is the angular and lamellar arrangement, there is no intercellular space, but in the tubular or lacunar type, there is intercellular spaces in some plants. Now the third simple permanent tissue, that is sclerenchyma. It is a non-living simple permanent tissue, and the main function is mechanical support. So the non-living mechanical tissue of a plant is sclerenchyma. It has a lignified cell walls which
helps us to see using the stain safranin. The safranin stain usually visualizes the dignified cell wall, so we can see sclerenchyma with the help of safranin stain. Now, basically, sclerenchyma is divided into two, that is fibers and sclerates. Now, let's first discuss fibers and then go on to sclerates. Okay, now the first classification of sclerenchyma, that is fibers. You might have heard about xylem fibers, phloem fibers, which is of complex tissues. The fibers that we mentioned here, there is also the same fibers of that sclerenchyma. Now, as it is a sclerenchyma tissue, it is non-living. It has a tapered end, similar to like this. A fiber has a tapered end like this, and it has narrow lumen. And usually I have mentioned before that it is non-living, but exceptional case is that is a phloem fibers of flax and hemp. The two plants have living protoplast. That's an exceptional case. You have to note that they have living protoplast. Now, the longest phloem fibers is actually of Bommeria nivea. It's a plant, so you should note this one also. These are to the entrance point, which might be asked from this part. So that's about we have to discuss about fibers in the entrance point of view. Now, the second type of sclerenchyma, that is sclerates. Now, we have mentioned about fibers, it has a tapering and a narrow lumen, so different shape is there. But in the case of sclerates, they do not have a particular shape, but a variety of shapes are seen. Accordingly, it is divided into these 5 types. Actually, there's some importance should be given to the first 4 types, but we can learn the last one also, that is the filiform type. The first one is brachysclerates. It has the sclerates in that type it has a more or less isodiametrical shape. Now, the importance of brachysclerates is that it is seen in the pericarp of fruits. Example, in the coconut shell and all, which type of sclerates is seen, that is brachysclerates. So you have to note this brachysclerates very much, because this might be asked in the entrance question. For example, which type of sclerates is seen in the coconut shell or pericarp of fruits? This is the answer, brachysclerates. Now, second one is macrosclerates. It is actually rod shaped one, and it is seen in the seed coat of leguminous plants. The third one is osteosclerates. It is actually bone shaped, and it is seen in the fruit wall and seed coat of many plants. Now, the fourth one is astrosclerates. It is actually stellate or star shaped, and it is also very important because it is in the leaf of many dicot plants. So a question might come from that point of view. And the last one, which is least important, that is filiform type of sclerates, and it is more like hair-like. So that's how we have to focus on simple permanent tissues. Now, so that's all for today's video. If you have any doubt or queries, please mail it to biontech@gmail.com and wait for more videos. Thank you.